operating VHF?
We will be using the portable repeater that's used by both Aries and GARS. That's one of the things that will be on the email list that will come out to you this coming week on the frequency, so you can go ahead and program your radio. If you have a radio, HT, that's already programmed with the Aries frequencies on it, it's on there. Okay? Any questions?
Okay, we'll move on to our program. I'm not the one doing it. We got Alan Murray, W4AJM, who's going to do it, and this is the new dress code for presenters. So,
We're going to have a hell of a time getting presenters from now.
I'll donate my tie, Earl.
there you go. So this is going to be Gwinnett Aries, SkyWarn, the National Weather Service, Public Safety, and you. Alan?
Okay, thanks. Now let me sound check since we swapped. Sounds good. Yeah, Good evening, everyone. My name is Alan Murray, W4AJM, and it is my distinct pleasure and privilege to be your presenter tonight. As John, could you dim the lights a little for us, please? Thanks. As Al said, the presentation tonight is entitled Gwinnett Aries, SkyWarn, the NWS, Public Safety, and You. It was Edward Bulwer who used this phrase that you probably heard before. It was a dark and stormy night, and I'm happy to report that the weather gods have cooperated, and I have terrific weather to go with the program tonight. Now, the good news is the rain will be over by 10 o'clock when we finish.
10 a.m. or 10 p.m.?
10 p.m. I will say I'm not a weather expert, and Steve, WD2OGY, you'll appreciate this, but when I was a Boy Scout, my favorite merit badge was weather. So I'm not a weather expert, but I am a trained radio operator. Having spent many years, like some of you, in ham radio, I understand net procedures, I understand emergency communications, completed the qualifications here. So that's what you and I bring to the table. Those of you that have been through the weather spotter course or will go through the one that's presented will be able to marry those skills with your radio skills, and you will be able to perform a valuable service in and around the community. Who can tell me what the significance of today, May 22nd, is? Anybody?
1 year's anniversary of the tornadoes in, was it Joplin?
Joplin, Missouri. Very good, Earl.
Do I get
You,
it right?
sir,
All right.
you, sir, get the first semi-valuable prize. This will make a very nice radio bag. And for those of you that participate, I have some other things to give away. Just remember, all decisions of the judges are final. Now, what I'd like to do is pass around, because Earl is very right. And this particular article is entitled Storm Spotter Classes, Stress Awareness in Wake of Joplin Tornado. And this is from the Columbia, Missouri newspaper on February 24th, 2012. So I'll just start these around. We can pass in each direction, and you can read this at your convenience. But the good thing about this is that storm spotters do perform a very valuable service, and what we're going to cover tonight is the reason for weather spotters, a review of Georgia severe weather phenomenon, reportable NWS severe weather criteria, and then spotter safety. Well, any questions before we begin? Now, I put some notebooks out there for you to take notes. Al is going to, or John's going to upload the presentation materials to the Gwinnett Area's website, so you can go there at your leisure and review this if you like. I do have two very nice handouts on cardstock, which you can take with you. They will be good in the shack or in the field to aid you in your storm spotting duties during a SkyWarn activation. And also, at the end of the presentation, I do have a relatively easy 15-question review quiz. So if you're ready, let's begin. Mark Twain said, "A great deal has been said about the weather, but very little has been done about it." And while that may be true, as I said earlier, as amateur radio operators, we have a very unique ability not to do something about the weather, but to help when severe weather strikes. Believe it or not, as Americans, we live in the most severe weather-prone country on Earth. And tonight we happen to have one of the three types of thunderstorms, which we'll be talking about later. And this happens to be simply air mass or single-cell thunderstorm, although there happen to be many of them in the area. And for those of you that may have studied up on weather or have been to weather spotter class, the type of thunderstorm that we're experiencing tonight is a relatively benign storm in the sense that it may bring some rain, it may bring some wind. Very rarely will it bring hail, and very rarely will this kind of thunderstorm spawn a tornado. However, thunderstorms, particularly the kind we experience here in Georgia and in the south and the Midwest of the country, produce more damage to property, more injuries, and more loss of life than any other type of weather phenomenon that the U.S. experiences, including hurricanes. Every year, Americans cope with an average of 10,000 thunderstorms. Think about that, 10,000 thunderstorms. 2,000, John, you said this worked well for you.
Don't know what's up.
It's my fat tongue, I'm sorry. 10,000 thunderstorms, 2,500 floods, 1,000 tornadoes, as well as an average of 6 deadly hurricanes. Now, Georgia happens to experience between 2 and 9 tornadoes per year, and when we get a little later in the presentation, I'll show you what is commonly referred to as Tornado Alley and how that relates to Georgia. And we'll talk about the type of thunderstorm that spawns that, and that's the one that we want to be particularly aware of, not only as residents of this area, but also in our duties as part of Gwinnett Areas and SkyWarn Net and spotters. Interestingly enough, 90% of all presidentially declared disasters are weather-related. That leads to 500 deaths per year and nearly $14 billion in property damage. And as Earl pointed out, this is the one-year anniversary since the devastating tornado in Joplin, Missouri, and there were 161 lives lost during that major outbreak. A little history on storm spotters. They were first used during World War II in and around artillery plants. After the war, they were used around military installations to protect property, particularly aircraft. And following the May 25th, 1955 tornado in Udall, Kansas, the National Weather Service decided to train their own spotters, and that has evolved into the Weather Spotter program that we now know today, and an offshoot of that, of course, is SkyWarn. SkyWarn is a program sponsored by the National Weather Service, and you do not have to be an amateur radio operator incidentally to be part of SkyWarn, so there are many people who attend spotter classes who are not ham radio operators, but as ham radio operators, we bring a unique capability to warning communities and relaying information to the National Weather Service and also public officials about severe weather, and that is because of the immediacy of the communication that we provide. And that will be very key, as you'll learn later in the presentation. Now, as train spotters in Georgia, we have to have a very good understanding of the kind of severe weather that we can experience here. And as I said, that will primarily be a supercell thunderstorm, and those are the ones that are capable of producing severe winds, tornadoes, severe hail, and flooding. Consequently, we must understand, and these are some of the things that we'll get to later in the presentation, but the visual clues regarding thunderstorm strength, in other words, how to recognize a supercell thunderstorm capable of spawning a tornado, and then also one of the things that we'll cover toward the end of the presentation will be how to make timely and accurate reports, and that will be very key. Any questions so far? Anything anybody wants to add? What do you think some possible uses of spotter information by the National Weather Service are? Anybody want to? You cannot win 2 prizes tonight, but I'll hate to tell you. Steve?
They use that information to get out the word for people potentially in the path of a dangerous situation.
Okay, to issue warnings. Very good. Sir?
Correlation of actual conditions to radar images.
Excellent.
Storm edge tracking. Storm edge tracking.
Storm edge tracking, okay? The direction of the storm. And perhaps strength and severity of the storm. Anybody else? Okay, survey says, verify other reports, confirm observed radar data, look for supporting radar or other data, and issue timely public safety warnings. So you got them all. Very good. Now, authorities use spotter information to probably almost the same things, right, John? Warning decisions, direct emergency personnel response, maintain the big picture perspective. Very important. SkyWarn spotter reports to the National Weather Service provide something we call ground truth. That's very important for the National Weather Service's perspective, and you'll see in the next couple of slides the reason for that. The weather radar, the NextRad radar down in Peachtree City, is about 75 miles south of Lawrenceville. And there are several limitations associated with radar, just like there are with radio signals, the kind that we use and communicate. And what might some of those be? Steve, you're an engineer?
Yeah. Yes. Obviously, there's path loss. Therefore, the signal strength of the return signal is not as strong when it's further away.
Attenuation. Very good. John?
The angle of the radar shoots at.
Angle of the radar. Very good one. That's important. You'll see why in the next slide. Over in the back, sir?
You have structural deviations such as buildings.
Okay. Also, ground clutter. Okay, very good. Something else, perhaps?
Backscatter.
Backscatter. All right, let's see what we've got. So this will be on the next slide, but so the National Weather Service uses this information to assist in present future warning decisions, confirm hazardous weather, and provide verification of the information. And that last bullet is really key. That's the ground truth. Because what the radar technicians, the forecasters, the specialists see on the radar is not necessarily what is happening on the ground 70 to 80 miles away. And here's why. I'm sorry, that's coming up in the next slide. So when you're making your responses, they have to be very helpful. And so this acronym will enable you to remember the things that you have to report. So if you can remember radio, you can do it. So they have to be R for relevant, A for accurate, D for descriptive, I for immediate, and O for observed. So I'll give you a minute to write that down. Radio, R for relevant, A for accurate, D for descriptive, I for immediate, and O for observed. So general question, when do you think a weather spotter report is most helpful? Is it, hang on Jeff, Jeff's over there, I'll give you, okay, I'll call on you Jeff. Is it A, before the severe weather event? Is it B, during the severe weather event, or is it C, after the severe weather event? Okay, Jeff?
I would say B.
And the answer is?
All the above.
Oh.
Because before, during, and after, those reports are going to be very helpful for the reasons that we mentioned in the previous slides.
Where's D?
So trick question, perhaps. And here's why. Aids in the issuance of additional warnings, proper emergency services response, and that real-time information, which they couldn't otherwise get. So you are the eyes and ears. Okay, now we're going to get into some of the limitations. Before we move on to some of the technical things, are there any questions? Is there anything anybody wants to add? John?
Yeah, I'm curious why it says before the event. To me, the risk there is somebody thinks it's going to do something and reports that, but that's not actually what happened.
Okay, let me explain it this way and see if this answers your question. There are several stages to thunderstorm development, okay? During the stage when it is building, particularly in the supercell thunderstorm, we have, depending on the moisture available, instability of the atmosphere, and the lifting force, because those are the three ingredients that are necessary to have thunderstorm development. And for a supercell thunderstorm to develop, and those are the kinds that spawn tornadoes and have severe hail, it takes a lot of energy, and the energy can be caused by frontal boundaries, and where you have a sharp division, and this is why most of the severe thunderstorms, ladies and gentlemen, happen in the spring, because we have a very sharp boundary between cold air coming in from the plains and warm air coming from the Gulf, and that provides the conditions that make it right for the severe convection, the updrafts and the downdraft, John, to produce the cyclone, the tornado. And there are lots of indications, and one of the later slides will show that can tell people on the ground that a tornado is about to form, and I'm sure you've all heard this term before, but wall cloud. And so a wall cloud indicates that there's this severe convective activity. There's an updraft in one section of the storm and a downdraft in the other storm, and the wall cloud is associated with the updraft. And it is this severe updraft reaching to 60,000, 70,000 feet in the atmosphere that causes, with a shear at the top, the rotation, to spawn a tornado. So one of the things that spotters can provide to public officials and to the National Weather Service so they can issue the warning is before the tornado actually forms and makes contact with the ground, the observance and reporting of a persistent rotating wall cloud is key. So that's why I say before. Did I answer your question? More or less? Okay. Hopefully more than less, John. So with radar, why do we need spotters? And we talked about those a few minutes ago. But radar has some limitations. Beam and height resolution is the main one. There are some other things, and I have it written down to let me check my notes. One is attenuation. The other is ground clutter. Beam height, beam width. And the radar's maximum tilt angle is 19.5 degrees. So 75 miles south of here, if the tilt is 19.5 degrees, the lowest segment of the beam is going to be several thousand feet off the ground. And over Lawrenceville, it may be 7,000 or 8,000 feet, which means if the cloud bases are 2,000 or 3,000 feet above the ground, there will be some indicators to the technicians, the specialists down at Falcon Field, of a hook echo or perhaps hail inside the tornado. But it's people like you and me with a radio in one hand and eyeballs glued to the thunderstorm in the other that provide the real-time information to help them issue the warning, because the radar can't see that and we can.
Yeah, the November 30, 2010 tornado that went through Gravel Springs in I-85 was never seen on the radar. Even when they played all the frames back. Oh, it's not there.
Okay, and one thing, and it probably wasn't beam height, but one thing that makes some tornadoes very difficult to see is because they are blanked out by rain. A rain-wrapped tornado is one of the most dangerous tornadoes because the rain column obscures the tornado. And the rain is generally on the leading edge of the thunderstorm because it's in the downdraft area, and the tornado is always on the backside in the updraft section. And so a rain-wrapped tornado is very dangerous because it's hard to be seen. And tornadoes at night, although that one I think was during the day, wasn't it, John?
Yeah.
Tornadoes at night are very difficult to
Right,
see.
school that out. Yeah.
And the other thing too, in parts of Georgia, because it's relatively hilly here, sometimes terrain obscures tornadoes. And if that was a weak tornado, I don't know what the strength was, F1 to F5, but a weak F1 tornado can oftentimes not be seen by radar. So this is what we do. We add credibility, we enhance public response, and we improve warning accuracy. This is perhaps the biggest limitation right here, the fact that the radar is 70 or 80 miles south of Gwinnett County, Lawrenceville, and so at the average tilt of the antenna, as you can see right there, 75 miles south, the radar is, quote, looking 7,600 feet above the ground. According to Google Maps, about 63 miles. So we can see what it can't. Now, a picture's worth 1,000 words, and this is kind of interesting because this is the eyeballs, the spotter. And this is what it looks like on radar. Unless you're very highly trained, could you tell that this and this, which are the same, just different radar depictions, that this and this equals that? But if the radar technicians at the National Weather Service hear you say that, bingo. And they can issue the warning, and we can also coordinate through our own net with Gwinnett County public officials, and that is why it's so important. Yes, sir?
And Lance, last, was it January we went down there, indicated that they're using new radar now that they don't know that well as well, so it helps to understand the new radar.
We're calibrating it for them.
Yeah, we're helping them
Okay.
calibrate.
Ground truth. So any questions before we get into the severe weather we experience here in Georgia? Okay, just a quick review then of some key definitions. So a watch simply means that conditions are favorable for the formation of severe thunderstorms, for flooding, for strong winds, etc. Yet a warning means the severe weather has either occurred or is likely to occur. So the warning obviously is more serious than the watch. The watch simply means conditions are right, and the warning means it either has occurred or is likely to occur. Carrying that over to a tornado warning. It means a tornado is occurring. Verified funnel cloud. Now a funnel cloud by itself, which emanates from a rotating wall cloud, is not enough to be a tornado. The difference between a funnel cloud that is rotating and a tornado is one big important fact. John, you want to try it?
Tornadoes on the ground.
Okay, tornado is on the ground. And the EC gets a semi-valuable prize.
Want to trade early? No.
Severe thunderstorms. Okay, to be a severe thunderstorm, winds of 58 miles per hour or greater and or 3/4 inch or larger hail. Yeah, that's pretty big hail. That's larger speeds, but 3/4 inch or larger. Flash flood warning has to do with 6 inches or more flowing water. And that's kind of key. And we see this a lot in low-lying areas next to stream banks where it has a tendency to run over banks. Flash floods can do lots of damage. The other thing about flash floods is that rising water can sweep cars away. Cars will float. The unfortunate part of that is you are usually in it. Remember the floods we had in September, or was it 2009? A couple of folks in Gwinnett County lost their lives because they were driving in the dark and they went into a flooded creek where it had overrun the road and ended up drowning. Very unfortunate. So the lesson there, of course, is do not drive into a flooded roadway because there may be a washout, maybe a big rut or gully, and you and your car may end up in their surf.
Over in Douglas County, not too long ago, a bridge washed out on a secondary road and sent several cars down the stream.
Yeah, water has some terrific force, as we remember from the floods of 2009. And so water, and we generally see this sometimes with severe thunderstorms, but generally with tropical systems that move on shore and come up through Georgia. And those are the hazards associated with those types of weather systems. So let's talk a little bit about thunderstorm climatology, as the slide says. Yellow and orange are where there's a significant number of thunderstorms per year, and in the Florida Peninsula, that's primarily caused by thermal lifting, heating of the ground surface. And there are three types of lifting mechanisms in order to provide what is necessary to build a thunderstorm. One is thermal. And that's the type of thunderstorm that we had today here in the area because the sun heats the ground, the air is unstable, there's enough moisture and it provides a lifting force to start the vertical development. Okay, the other type is called orographic, and that's caused by terrain features, and that's why sometimes if you watch the evening weather, you'll see the weatherman or the weather lady talk about some thunderstorms in the Georgia mountains. And orographic lifting is caused by warm, moist air moving upward over terrain features. And the third type, which is where we generally see severe thunderstorms, is called frontal lifting. And that's where there's a very sharp division between air masses. We have a very cold air mass coming down through the plains that's mixing with a very warm, moist air mass coming up from the Gulf. And you'll see that generally occurs right in here where I just pointed the laser, and that is known as Tornado Alley. Because it is that kind of sharp division that not only provides the lifting, but also provides the mechanism for the severe updrafts and downdrafts that give rise to the tornado. And as meteorologists would say, that is known as tornadogenesis. So this is Tornado Alley. And the next couple of slides will show when most tornadoes form during the year. And it just so happens that May is peak tornado month in the United States. And we're toward the end of May, but we're not out of the woods yet. You can see here from this slide that May is the peak, followed next by June. And June 1st is the official start of the hurricane season, although I think with the warm sea surface temperatures, we're going to be in for very brisk hurricane season. There have been a couple of tropical storms off the Atlantic coast. So April, May, June, and then July, and then it tapers off. And that's because of the clash of the air masses in the central part of the United States, and Georgia just happens to be on the leading edge of that. Also, if you take a look at this slide, you'll see that from 2 p.m. to 8 p.m., so a 6-hour window, is when most of those tornadoes occur. And the reason is because that part of the day is as far as tornado and supercell thunderstorm generation goes, aided by thermal lifting from the sun's rays hitting the Earth's surface. So this is a classic supercell thunderstorm, as the slide says, and you can see this with what's known as a hook echo. And if you've watched Channel 11 or WSB TV during a severe thunderstorm, you've heard them talk about that. And the diagram looks like this. So if you translate this to this, you can see the hook echo right here. And notice that this is a cold front going into an occluded front and another cold front. So the frontal system signifies the division between warm air, which would be over here, and cold air over there. Where we have that sharp division, we have a lot of energy, and it's going to facilitate vertical development. And the hook echo is very important because this is the region where we have the severe updraft and the severe downdraft. And it's like a conveyor belt. One sort of feeds the other. And this particular region right here is called the RFD, or the rear flank downdraft. And adjacent to that, the downdraft is going to be warm, moist air because it comes from the middle of the cloud, say 20 to 30,000 feet. And then the updraft is going to go to 50 or 60,000 feet. And it is that updraft, if it has rotation caused by shearing, and shearing simply is where you have low altitude winds going in one direction and high altitude winds going in another, and it causes rotation. Everybody got that concept? And it's facilitated by the fact that this represents a low pressure system, and the low pressure system spins counterclockwise. So there's already a counterclockwise motion, and high altitude winds, particularly from the jet stream, can give it that extra kick. And if there's a significant updraft, the rotation caused by the shear in the jet stream will be enough to cause the wall cloud to form. If the updraft becomes more severe, a funnel cloud can develop, and if it is persistently rotating and touches the ground, then we have a tornado. Let me just back up here. So you'll see in a couple of slides, if you were a spotter and you could, not that we want you to run out and be storm chasers, Kyle, but where would the best position to report on that storm be? Where do you think?
Underground.
Underground, very good, Jack. Yes, in the storm cellar.
East?
Okay, so let's just, it's north. The best place, believe it or not, would be here. Because remember, there's going to be a lot of rain here. It may be very difficult to see the tornado. So if you happen to be, if this is some part of Gwinnett County, say Lawrenceville, what would be up here? Gainesville. Okay, so that might be, so again, if you happen to be looking at the weather maps on the television, and you can see this, you know then that you may be in a good position to provide that ground truth for the National Weather Service just based on your position. Okay, these are a couple of things that I talked about before, just to relate it back to this, particularly that slide right there. This is the RFD, which is the rear flank downdraft, and this is the updraft. So the tornado forms right there. And that is the classic hook echo that you will hear weather people talk about. Something else associated with the hook echo, besides rain and a possible tornado? Anybody want to, yes?
Employment.
Employment, yes. Grab your
Work for FEMA.
Grab your go kit.
Hail.
Hail. Okay, hail is a very important indicator to the National Weather Service about the possibility of a tornado, or the probability of a tornado, because it takes significant updraft to carry hail to the top of the cloud where the moisture freezes. What happens is that the hail goes back to the bottom of the cloud, and then it gets caught in the updraft again, and so it's like a conveyor belt. And it goes up and down until the point where it becomes large enough, read heavy enough until it falls out the base. So the larger the hail, the more severe the thunderstorm. The more severe the thunderstorm, the greater probability that it will spawn a tornado. And very often, a tornado is preceded by hail And after the hail stops, there is no rain, and the next thing is that
Train.
rain. So there's the best viewing angle because you can see right up there, there's generally a rain-free area. It's on the back side. Remember I said it's difficult to see a rain-wrapped tornado. So if you happen to be looking at the television and the real-time radar and you can put this together, you may be able to offer some very important information. Another good viewing angle is directly behind it. Now hopefully the tornado didn't spawn and then go over you when you were behind it. Any questions so far? Okay, let's talk about wall clouds and then we'll talk about shelf clouds, and there's a very distinct difference between the two, and it's very important to understand what a shelf cloud is versus a wall cloud, because they're both very important, but the wall cloud is the single most important precursor to a tornado. So I mentioned before the downdraft and the updraft, and the tornado will form here in the updraft region of the supercell thunderstorm. Now notice it's called a supercell thunderstorm because it breaks out at the top. And so if you watch local weather radar and they talk about how the tops are here and you'll see the different colors. If they say something about how it has broken out the top, that's a good indicator that it's a supercell thunderstorm and is capable not only of producing hail, but producing a tornado. So we have back here the RFD, so the rain, the rear flank downdraft, then the updraft, and then this is called the rain-free area. And so this is almost like a conveyor belt. So the updraft is cold air that's being pulled up as the warm air containing the rain column, moves down. And notice that these arrows here are indicating some kind of rotation. And the rotation is facilitated by the high altitude winds as the top of the storm breaks out into the jet stream region, some 30 to 40, even 50,000 feet above the Earth's surface.
Alan, isn't that the other way around? The warm air, the warm humid air is rising and the cold rain is coming.
Now, believe it or not, the updraft is a column of cold air. It's being pulled up the top.
Test question.
And there's a test question. Let me just double check, John, make sure I got this correct. I don't want to tell you that it's not true.
See? Sometimes that's not the way. But the cold air is good.
Johnny Ray, I'll take that back. The shelf cloud where the downdraft is, you'll see the shelf cloud over here, is the cool air, and that is the warm air, so I stand corrected.
And besides, the red usually is hot and the blue is usually cold.
And that's why you're an engineer and I'm not. So,
Okay, what does he win for that? We have a winner.
We have a winner.
Okay. All right, so let me backtrack here and correct myself. The wall cloud forms here, the updraft is the warm air, and the downdraft is the cold air, and it's like a conveyor belt. So in the next slide, you're going to see the shelf cloud, and the shelf cloud is going to be located here, and the wall cloud is going to be located here. And the wall cloud is very important because that's where the tornado will form.
Now, part of the reason the air is rising, you referred to it earlier, is the difference between the temperature up high, which is cold, and the temperature down below. And that's why you get them in the early spring and even in November when you have bigger differences in the temperature and that cutoff layer up there is the stratosphere where the lapse rate changes. And and that's why it stops rising there, except it's got momentum and it goes up through it. But the reason the air is rising is it's rising into cooler air, therefore it's condensing. Condensation produces heat, whereas evaporation consumes heat. And so that's why it's unstable. The reason it's unstable is it keeps rising faster and faster because of the condensation the heat gives off. That makes it warmer than the surrounding air, which makes it float, which makes it go up, and that's why they get going so fast.
Is that like hot air rises?
That's what I heard.
Well, it's the fact that the air is humid and warm, and the temperature, you have this temperature difference so that it's rising in the cooler air, but it's giving off that heat condensation.
Okay, I'll buy that. And again, we're not trying to make meteorologists out of anybody. And as I said before, I'm not a weather expert. And this slide may help to explain it. You're welcome to go and read about it. I saw it on the internet. It must be true. This is a very good. This is a very good slide that depicts some of that. You can see it's very complex. We have this updraft that we've been talking about. And there's the warm air into the overshooting top of the tornado. As the funnel cloud comes through the wall cloud and touches the ground. We have the rear flank downdraft, the RSD that I referred to, and then we also have a forward flank downdraft, and that's associated with something that's very common. It usually precedes a thunderstorm by 10 to 15 miles, and that's called the gust front. So again, you're welcome to read about this. Personally, I think it's fascinating, and the more you learn about it, the safer you will be when it comes to being a weather spotter, the better job you will be able to do, and also you will be able to protect yourselves and your property and your family. So you're welcome to read about that, but I think the takeaway is that it's going to be the updraft that is associated with the wall cloud that is associated with the formation of a tornado.
But isn't that gust front with the straight line wind that can sometimes cause almost
Yes.
as much damage?
Yeah.
And it's oftentimes very localized, about 2.5 miles for a microburst is about what the diameter is. And if you hear people on the radio after a severe thunderstorm talking about how the trees are down and the National Weather Service is going out to look, one of the things they do to determine whether it's straight line wind damage, i.e. a microburst or a downburst versus a tornado, is how the debris is scattered. Trees that are twisted in every direction generally indicate a tornado, whereas trees that are laying flat emanating from one central point, which would be associated with a microburst or downburst, are that phenomenon. So wall cloud. This is a good picture of a wall cloud, and this would be an area of the updraft. And as the slide says, it's surface base next to the inflow, and that's the key, because you have air going into the base of the supercell thunderstorm, into the updraft region, and if there's any rotation, it will be apparent first in the wall cloud. And the key to, and what's very helpful to report, is that if the wall cloud forms, and it has rotation, and it is persistent. Now the rule of thumb is if it persists for 10 minutes or more, but if it's persistent and it's rotating, and in some cases they undulate, they do this from the cloud base, but those are things that you want to report right away, because that will enable the National Weather Service to issue a warning. Any question on the wall cloud? So the shelf cloud then is in the front, and this is the FFD, the front flank downdraft, and this is associated with the gust front. This is where the rain is because the column of air is moving down. It's coming from, as John corrected me, the top of the cloud, so it's much cooler air. Okay, now there's this shelf cloud, and it looks similar to the wall cloud, but there's a distinct difference. As I said, rain-cooled air. It's generally on the FFD, the front flank downdraft, but it can be on the rear flank downdraft, associated with low-level wind shear. So you have winds at one altitude moving in one direction, winds at one altitude moving in another direction. And as a spotter, it's very key that we know and be able to report the difference. And the one that's reportable, of course, is the wall cloud, particularly if it's rotating and the rotation is persistent. So here's the difference. Funnel clouds do not form on a shelf cloud. Okay, funnel clouds will be associated with a wall cloud because that's where the updraft is. Another key point to remember, a low-hanging cloud in the shape of a funnel, if it is not rotating, is not a funnel cloud. So a funnel cloud has rotation. That make sense? So a wall cloud may or may not rotate. A wall cloud that's rotating and the rotation is persistent is reportable. A funnel cloud can emanate from a wall cloud, but a funnel cloud isn't a funnel cloud until it rotates. That makes sense? So it'll be supercell thunderstorm, wall cloud, rotation, funnel cloud, contact with the ground, tornado. Big difference, funnel cloud does not contact the ground even though it's rotating. Tornado is a funnel cloud that's rotating and has made contact with the ground. This will all be on the website, but this may be one that you want to print. I do have a couple of handouts that you can take with you, and I don't remember if this is on there, so let's just step through this very quickly. So the differences between wall cloud and shelf cloud. Wall cloud is associated with the updraft, shelf cloud is not. Wall cloud is just the opposite, not associated with the downdraft, but the shelf cloud is. And that's it. Funnel cloud. It rotates and does not reach the ground. So is this a funnel cloud or a tornado? It depends. If it's touching the ground, it's a tornado. We can't really tell. There are some clues, though.
Start to pick up debris off the ground.
Okay, debris is a very good one, and that's probably the most noticeable thing. There does not have to be debris, but that is a very good indicator, and that would be reportable. Another semi-valuable prize. Yeah, transformers. You can see the flash, and a lot of times tornadoes at night, when they play the video the next day, you'll see that. So the difference between a funnel cloud and a tornado, they both rotate, but the tornado touches the ground. So this one, what do you think? What?
It may not be. Sometimes you can't tell.
Tornadoes can't
tell.
touch-
You just tell, say, what you see.
Tornadoes can touch the ground, Steve, yes, but they may not necessarily have debris. Red light. Some tornado indicators, I mentioned this before, and again, this will be on the website, but these are things that you may want to write down and try to remember. Very often, observers or eyewitnesses report a greenish tint to the sky. Mike shaking his head. Any idea what causes that? John? A lot of times,
Light refraction off the condensation.
condensation and particularly hail. Remember I said hail, a severe thunderstorm with hail is sometimes, if it's a supercell, very probable tornado producer. Okay, mammatus clouds. Mammatus, Latin for cow's udder, but those are the things that sometimes hang under the cloud bases. They can give rise to a wall cloud. Sudden drop in barometric pressure, because these are generally associated with a low pressure system and the updraft. Large hail, 3/4 of an inch in diameter. Strong winds in excess of 60 miles an hour. Frequent and intense lightning. okay, indicating a severe storm. Rotating wall cloud, and again, that is key. And the classic freight train sound. Other thunderstorm phenomenon, we talked about this one, the hail shaft. Okay, that will precede the tornado in most cases. It will be rain and then hail and then tornado. Now we're going to talk about what is reportable criteria. And SkyWarn Net, this is right off the Good Areas website. So John, you want to run through this for us? Or do you want me to do it?
Go right ahead.
Okay. Didn't mean to put you on the spot.
You have the microphone.
Okay, SkyWarn Net will be called if the county's under a severe weather warning. May be called if it's under a watch. May be called if severe weather is spotted, or when requested. Get them all, John? Okay. This is really key. Remember radio? Okay, it's got to be relevant, accurate, descriptive, immediate. I spell it right,
Observable.
immediate and then observed. So accurate is key, and timely information has got to be immediate. And the reason, very simply, is lives and property could be at stake, particularly lives. So we play a very important role. Now, this is a net. It's a formal net, and so again, much of your time, if you're checked into the net, will be spent listening, unless you have a report to make or priority traffic. And again, just a side comment, if you haven't volunteered to be an NCS or an NCS, it's a great opportunity to learn, because someday you may be the operator that's the only one available to run the net. That's not the time to learn how to do it, right, John?
I would like to add one thing on that. There will be time, I mean, one of the reasons that we do the rotation of everyone taking a turn as net control is not just to give you busy work. The idea is to get over kind of the first phase, mic fright, whatever, of actually conducting a net. It's all scripted, that's nice and easy to do. But the next thing is that also prepares you that if there is a time that we need to start a severe weather net, a SkyWarn net, and one has not started, there is a warning, for example, in the area, please take the initiative to go ahead and start a net. Because Jan, Kyle, me, anyone might not be available, might be out of town, but it's important, and you will not be chastised. Better to have the net than not have the net. So feel free to jump in. You might ask if a net is started, if there is a warning. And I think we may have even had a warning yesterday, and I was out of the area, so we may or may not have had a net. I know Jan is out of town right now. They're in Tennessee, so they're not going to be the ones that initiate it. Feel free to jump in and start a net. And I think you've all heard them, so you know the idea.
There was a net, Sandy took the net yesterday.
Couldn't hear you.
I'm sorry, you're right.
Okay.
And net controls also need some rest, so if you're checking into a weather net, and the NCS says, can you take the net for 20 minutes while I go take a break because I've been doing it for 2 hours? You need to consider that very seriously.
Okay, thanks. I'm going to go through the reportable criteria slides rather quickly because I have some handouts, and this will all be on the website. But here's some important things to remember. The National Weather Service in Peachtree CD does not want these reports. These are not reportable criteria. And rain of less than 1 inch per hour. 2 inches is the threshold, by the way. Lightning if no damage. wind less than 40 miles an hour. Remember, severe thunderstorm criteria, 58 miles per hour. Hail smaller than penny size. So quarter size is reportable. Situations with authorities already present. And information heard on official radio. Don't rebroadcast. Okay? So, don't call in and say it's raining in public, right, John?
Or that I heard it, I just heard this on WSB.
It's raining at my location.
So. Okay, any questions? So, reportable criteria, here we go. A funnel cloud, a tornado, or a wall cloud.
Tornado.
Remember, wall cloud with rotation that is persistent. A funnel cloud will be a rotating cloud emanating from the cloud base. Or tornadoes, funnel cloud with ground contact.
Tornado.
That's reportable. Strong or damaging wind, 58 miles per hour, 58 to 60. You can estimate, one of the handouts I have for you later helps you estimate the winds. Kyle, if you're out there and your hat goes away, that's probably reportable.
Then we have reportable criteria.
Yeah. If the rest of your hair goes away, that's definitely reportable. Okay, here's how you can estimate wind speed. So right there, ladies and gentlemen. So if you're out there and you're having trouble walking, that's reportable. Actually, that's a better thing right there. Just a quick talk about this. People tend to get excited during emergencies, so they overestimate, parentheses, exaggerate, all right, stress, excitement, tension. So what may be 30-mile-an-hour wind suddenly becomes hurricane. Hail. So what size hail is reportable? Don't say marble-sized hail because marbles come in different sizes. Best to use something that's common. Ping pong ball, golf ball. Coins work very nicely, and you can see them there. Damage, flooding, okay, high water, so low-lying areas, rising creek. Maybe you may help the National Weather Service or local authorities issue a flash flood warning. How do you make a report? Okay, we already said radio, right? Relevant, accurate, descriptive, immediate, observed. So be sure of your observation. Okay. Formulate your report. Know what you're going to say before you say it. Include the type of event you're reporting. Know your location at all times. And advise net control you have a report. Wait for the net to acknowledge, and then provide a concise description, provide direction and movement of the severe weather. Very easy. So we talked about radio, R-A-D-I-O, and just the 5 W's. Who, what, where, when, what. Who you are, what you've seen, where you saw it, when you saw it, and what it's doing. Very simple.
What?
Who you are, what you see,
what it's doing.
where you saw it, when you saw it, and what it was doing.
What you saw, what it's doing. What?
So here's an example. It's got all those elements in there. And again, just kind of formulate it because there may be other reports and you want to keep the net efficient. Pass the information as quickly as possible and provide an opening for other stations to report. So brief and to the point. Any questions before we talk about spotter safety and get to the quiz? Much of this is common sense, so I'm going to go through these slides briskly because it's getting late, but don't try to be a hero because you could become a storm statistic. You don't want any statistics, do you, John? Lightning is probably the most dangerous thing associated with being a weather spotter. Next one would be flash flooding and rising waters. Very difficult to see tornadoes at night. Lightning is not necessarily going to help these. So you need to be very careful with severe thunderstorms in the area if you are outdoors and trying to provide some assistance. So any questions, anything anybody wants to add? If not, let's pass out the quiz. And we'll pass out the handouts.